Alright guys, so on this version of the lesson today, we're going to talk about writing chemical equations. So we've just talked briefly and you've taken notes on the components, but now you're going to learn to put it together beyond identifying reactants and products and actually making it a sentence. So as we talked about before, a chemical equation is just a sentence that's shorthand because scientists are lazy. So today, by the end of this PowerPoint, if you're taking notes and you're doing the practice, you should be able to know that compounds are two or more elements that are chemically combined, but you've known that since quarter one. You should be able to describe the information in a chemical equation and apply the principle of conservation of mass. We'll get to what that means in a little bit. So if we review, a chemical reaction is just when one or more substances turns into a new substance. You've seen this before when you do your labs, but ways to tell this are color change, bubbles. If it forms a precipitate, that means when you mix two liquids together and you get a solid at the bottom. A change in temperature, so if it either heats up or cools down, or a change in smell. All of those are signs of a chemical reaction. Molecules are made out of two or more elements joined together, and atoms are bonded by valence electrons. Valence electrons are around the outside of the atom, and they either share, as in a covalent bond, like we talked about holding hands, or they transfer when you draw the arrows for an ionic bond. When they bond together, though, it actually makes a new substance. You have a new compound. So for NaCl, this is an ionic one that you've seen, and it's a transfer of electrons. The Na electron goes to the chlorine gas, so the chlorine has a full shell, and now you have a sodium ion. And NaCl together is actually just table salt. Then you have covalent bonds. Covalent bonds are a little bit different. It's like everything holding hands. So you have two H2 bonded together, because H2 only exists together because they only have one valence electron, otherwise they'd be so reactive, and then the oxygen are bonded together. Those are called diatomic molecules. You'd put two of each of these things together and you end up with two molecules of water, or two H2O. So you know what compounds are. Properties of compounds are very different from their actual pieces. For instance, sodium is a metal and chlorine is a gas, and together it just makes salt. But they can be chemically separated, which means you can heat them to be different and other things like that, or do some sort of chemical reaction. So here are an example of compounds that you know. You know sugar, salt, and water. Those are super easy. You can get them at the grocery store. You can find them in naturally occurring places. They're just compounds that are bonded together. A chemical formula is what we're really going to go for, and that's something that you've been practicing writing. You've written it for ionic bonds and you've written it for covalent, and that's just the combination that represents the elements, and they're always written with subscripts in the lowest ratio possible. When you're writing a chemical equation to talk about how these transfer to each other, that's a shorthand sentence. So instead of using words, you use their symbols. You would not want to say, like you see below, calcium carbonate degrades into calcium oxide and carbon dioxide. That's a lot of words and a lot of spelling in a sentence that's as simple as just writing three different compounds, an arrow, and a plus sign. So in a chemical equation, you have your reactants, which are the substances that are present at the beginning of a reaction. They're what you use to make a reaction, and they make a product. So a product is something at the end. Always think reactants before the arrow, products after. So in this one, the CaCO3 is your reactant, and your products are CaO, and CO2. How you determine how you do this is the conservation of mass. All it means is that you can't create or destroy matter. So what you start with in the beginning has to be accounted for at the end, just mixed up in a different way. And we do that by balancing a chemical equation, which you'll get to at the gold level of this module. But chemical equations have to be balanced because the same amount present has to be there before. That's our law of conservation. So that means that you have the same number of each element on both sides. So if we look at an example here, it says we have 4 iron plus 3 oxygen make 2 rust. So which statement below best describes the process shown in the equation? Of these answers, iron is combined with oxygen to form rust. Answer B is your best option here. And you can also do it with word problems, which is the practice that you'll see in your module packet after you watch this video. So when solid sodium and chlorine gas react, they form sodium chloride. That is the same thing as just writing these three. 2Na plus Cl2 makes 2NaCl, and all you just wrote was the sentence to form salt.